What's up, everybody? This is Mr. Richardson coming at you live through the power of the internet. And what we're going to be discussing today is how do we predict election results by using computer simulations. If you're just getting here now, make sure you've checked out my previous video, How Do We Draw Conclusions About Sample Surveys Using a Computer Simulation. A lot of what we did in that video is going to be the prerequisite knowledge for what we did today. I'll leave a link to that video in the description below, and while you're here, make sure you click that like button and hit subscribe. Let's jump right into it. Computer simulations are very important regarding elections. If we think back to the 2016 presidential election, before the voting was in, Hillary Clinton was actually a big favorite to win that election, but did not win. Had we had some computer simulations, we may have seen that Donald Trump had the chance of winning the election and was very probable to win. We could have also seen that the information that we had regarding that Hillary Clinton should win was very inconclusive. Let's review how to conduct a computer simulation. The first step is to assume some value of interest. For elections, we're going to assume that we have 50% of the vote, but we're predicting what should happen. This what should happen, or this assumed value, is not what actually happened in our sample, but what we kind of want to happen. Step 2 is to run a computer simulation based on the assumed value. We run a simulation a lot. We want to do it 100 times, 200 times, 500 times, even 1,000,000 times to see what could happen with our assumed value. Because it's likely that we can only conduct this survey 1 time or 2 times, we let the computer run it 100 times or 200 times so we have an idea of what might happen. Step 3 is to count the number of times that the sample value showed up in the computer simulation. We're actually going to count. Did it show up 1 time, 2 times, 10 times, 100 times, and etc. We're also going to include values more extreme than the value from our sample. So if our sample value is less than the mean, we'll include the values less than that because that's an even more extreme scenario. And if our sample value is greater than the mean, we'll include the values that are greater from it. In step 4, we want to determine if this happened a lot of times or a few times. In step 3, we counted how many times it happened, and now we want to get a percentage. How many times did it happen out of how many simulations, be it 100 simulations or 200 simulations? Anything less than 5%, we'll consider that it didn't happen a lot or as few times, and anything more than 5%, we'll consider that it happened a lot. In step 5, we'll decide if the claim from the sample is reasonable or unlikely. This is not a gut feeling, and it's based solely on having many cases or few cases. Remember that many cases is anything above 5%, and few cases is anything under 5%. Let's jump right into an example. This question reads that there's an upcoming election for Teacher of the Year, and I must get 50% of the vote to win the title. A poll was taken of a random sample of 100 students from the high school, and 52 students said they would vote for me. Simulations were done with a population percentage of 50% and a sample size of 100 to see how likely a sample of 100 would have 52 who preferred me as their candidate for Teacher of the Year. The results of 200 simulations are shown below. What conclusion can be drawn regarding the likelihood that myself will win Teacher of the Year with more than 50% of the vote? Before we show the results of the computer simulation, I want to consider this scenario. Here we see a school population of 200 students where 50% of them would vote for me for Teacher of the Year. Now imagine what happens if of these 200 people in our population, I only pick 100 of them. Many different scenarios could arise for how many of them would vote for me for Teacher of the Year. Imagine out of this population of 200 students, my sample was this 100 students. Well, if I picked this 100 students, 100% of them would say they would vote for me, where in reality, out of all 200 students, we know that only 50% would vote for me. Let's pick a different sample. If I picked this sample here of 100 students, we can see that I would get back 75% of the students would vote for me, but in reality, I can see of the 200 students, only 50% were going to vote for me. Let's pick another sample. Let's imagine out of the population of 200 students, I pick this sample of 100 students. Well, if I had polled these 100 students, I would see that only 20% would say that they'd vote for me, when in reality, out of the population, 50% would. And finally, look at this sample of 100 students. If I picked this sample of 100 students, I could see that 52% said they would vote for me, when in reality, only 50% of them would vote for me had I asked all 200. We want to keep this information in mind when we look at our sampling distribution. Here we can see a sampling distribution from our 200 simulations. What this shows here is a bunch of little dots, and every little dot is the result of picking 100 students. This little dot here, that means of the 200 simulations, one time that I did this, 62% of the students said they would vote for me. These 3 dots here show that of the time I did this simulation, I did it 200 times, 3 of those times, 60% of the students said they would vote for me. Well, when I did this in reality, what had happened was I saw that 52 students said they would vote for me out of 100, so 52% said they'd vote for me. Now what I want to see is if I actually had 50% of the students, much like in the example I just showed you, how likely would it be to get 52%? First thing we have to do is find 52% in our computer simulation. Here's 50%, 51%, so 52% is right here. Now we highlight in our simulation all of the times that 52% or greater happened. Because 52% is larger than the average of 50% that I ran the simulation on, I included the values to the right. Here I'm seeing how often did 52% or greater happen. I can see here that it happened quite often. Out of the 200 simulations, this happened 71 times, or 35.5% of the time. What that means is that assuming I only had 50% of the vote, if I asked 100 people, obtaining 52% of the vote would happen very often. It would happen 35.5% of the time. So what this means is that it's very likely that I actually had only 50% of the vote. So if I only have 50% of the vote, does that mean I'll win the election or lose the election? Well, we're actually not sure. Remember that I have to have more than 50% to win the election, so only having 50% doesn't give us a lot of information, and we're uncertain. We can conclude that the simulation shows many cases. Remember, it showed 71 out of 200 cases. So it showed many cases with a sample proportion of 0.52 or greater. So we can conclude that we can't tell if I'll win the election or not, and the results are inconclusive. Let's see if you could try one of these problems on your own. This question reads that there's an upcoming election for student council president at a high school. Amy must get 50% of the vote to be elected. A poll was taken of a random sample of 40 students from the high school, and 28 students said they would vote for Amy. Simulations were done with a population percentage of 50% and a sample size of 40 to see how likely a sample of 40 would have 28 who preferred Amy. The results of 200 simulations are shown below. What conclusion can be drawn regarding the likelihood that Amy will win the election with more than 50% of the vote? First thing I do in one of these questions is figure out what was the proportion from our sample. Here I can see that Amy got 28 out of 40 votes, or she got 70% of the vote. If you only need 50% of the vote to get elected, that means that based on this sample, Amy would absolutely be elected. Now we want to decide, is it actually possible that Amy only had 50% of the vote, but we asked the right people and saw that we got a number as high as 70, so that's why we run the computer simulation. We're running the computer simulation based on an assumed value of 50%. We're going to assume for a minute what would happen if Amy actually had 50% of the vote. Would it be possible to get 70% back? And when I look at this computer simulation and the results, we can see that 70% didn't show up very often, and further, the numbers higher than 70%, if we include those as well, didn't show up often either. Those only showed up 2 times. Now, we ran this simulation 200 times, and seeing that it only showed up 2 times out of 200 simulations or 200 trials means that this only happened 1% of the time. So if we actually had only 50% of the vote, it'd be very unlikely that we'd get 70% back from a sample of 40 people because this only happened 1%. So assuming Amy actually had 50% of the vote in our population, obtaining 70% of the vote in a sample size of 40 would not happen very often. It only happened 1% of the time. So the results of the simulation show few cases with a sample proportion of 0.7 or greater. It's few cases because there was only 2 times out of 200 trials, and greater because we included the values to the right of the mean of 0.5. So what does this say about Amy's chances of winning the election? Well, it's very unlikely that Amy only had 50% of the vote because there was few cases, which means this 70% is statistically very significant. Had Amy only had 50% of the vote, we wouldn't really get a value this high. So this value of this high must mean that Amy will most likely win the election. Let's try another problem. This problem is very similar to the last one. In this one, Brian is running for student council president, and he needs 50% of the vote. Here we took a poll of 80 students from the high school, and 34 said they'd vote for Brian. Simulations were done with a population percentage of 50%, and again a sample size of 80, to see how likely a sample of 80 would have 34 students who preferred Brian. The results of 200 simulations are shown below. What conclusion can be drawn regarding the likelihood that Brian will win the election with more than 50% of the vote? First thing I like to do is see what happened in the sample. Here, 34 out of 80 students said they would vote for Brian, which is only about 42.5%. Now what this means is that Brian, based on our sample, does not have enough votes to win the election. You need to have more than 50% of the votes to win. So what we do is we run the simulation assuming maybe Brian did have 50% of the votes, but we asked the wrong students in that sample size of 80. Shown below are the results of 200 simulations. Remember, each one of these dots is one of 200, which tells us the results of doing this simulation one time. So this little dot here, what that means is that if we ran one simulation, we got 35% of the votes for Brian. Now we want to see where is 42.5% on our simulation. It's right here. That is 42.5%. And because it's to the left of the mean of 50%, we want to include the values less than it. Here I have highlighted or circled out of 200 simulations how many times a value of 42.5% or less showed up. That showed up 31 times out of 200 simulations, or 15.5% of the time, which is greater than 5%, so it's showing that this is very likely. What that means is even though we only got 42.5%, it's very likely that we could have had 50% of the vote and just asked the wrong people. So to summarize, assuming Brian actually had 50% of the vote in our population, obtaining 42.5% of the vote in our sample size of 80 people would happen very often because it would happen 15.5% of the time. What this means is it's very likely that Brian actually could have had 50% of the vote. But think about it. If Brian did have 50% of the vote, do we think he would win? He'd probably need more than 50% of the vote to win. So right now we really don't know if Brian's going to win or not. He might have 50% of the vote, but even if he does have 50%, that's not commanding enough to win. We certainly can't say he's going to lose because he could have 50%, but we also can't say he's going to win either. So to summarize, we can say the simulation shows many cases with a sample proportion of 0.425 or less. We said many cases because we saw 31 out of 200, and we said or less because we included values to the left of the mean. Of course, our results are inconclusive. We think he might have 50% of the vote, but that's not a dominating number because it's not very high above 50 to say that he'll win the election, and because he might have 50%, we also can't say that he'll lose the election. Let's try another example. This problem is very similar to the last two examples. Carl is running for student council president and of course needs more than 50% of the vote to be elected. A poll was taken of a random sample of 50 students from the high school, and 17 students said they'd vote for Carl. Simulations were done with a population percentage of 50% and a sample size of 50 to see how likely a sample of 50 would return 17 who preferred Carl for student council president. The results of 100 simulations are shown below. What conclusion can be drawn regarding the likelihood that Carl will win the election with more than 50% of the vote? First thing I always do is calculate p-hat, or the percentage from our sample. In this case, 17 students said they'd vote for Carl out of a sample size of 50, which means 34% of students would vote for Carl. We know that Carl needs above 50% of the vote, so based on our sample, it's likely that Carl won't get elected. What we want to know is it possible that we actually had 50% of the vote for Carl, but we just asked the wrong 50 students, and that's why we run the computer simulation. We run the computer simulation based on having 50% of the vote, and we did that 100 times. Each one of these 100 dots represents the results of a computer simulation. We want to find where is 34%, and if I look, 34% is right here. If I look at how many times 34% showed up in our simulation, it only showed up 2 times. So how likely is it that Carl might actually have 50% of the vote? Well, 2 times out of 100 simulations is a very low percentage. That's only 2%. Because 2% is less than 5%, we can say it's very unlikely that Carl actually had 50% of the vote. If we actually had 50% of the vote, this 2% confirms that it would be very unlikely to get something as low as 34% in a sample size of 50 people. Well, if it's very unlikely that Carl actually had 50% of the vote, and in our sample he only had 34% of the vote, we can say that Carl probably won't be elected. This is because we had very few cases with a sample proportion of 0.34 or less. We say few cases because it was only 2 out of 100 cases, and we say or less because we also included values to the left of the mean, even though in this case there was no value smaller than 34%. The results from the survey show that Carl will most likely lose the election. Let's try one final example. This question here is very similar to all of the other ones we did today. There's an upcoming election for student council president, and Danny is running, and he must get 50% of the vote to be elected. A poll was taken of a random sample of 40 students, and 26 students said they'd vote for Danny. Simulations were done with a population percentage of 50% and a sample size of 40 to see how likely a sample of 40 would have 26 students who preferred Danny. The results of 100 simulations are shown below. What conclusion can be drawn regarding the likelihood that Danny will win the election with more than 50% of the vote? To answer this question, we should first start with the sample. When I look at p-hat, which is the sample proportion of 40 students, we can see that 26 of them said they'd vote for Danny for student council president, which is 65% of the vote. This is very high. It looks like Danny should win the election for student council president. We just want to see, is it possible that Danny only had 50% of the vote and we just asked 40 students that were likely to vote for him? And that's why we run the computer simulation. We run it based on 50%, and when we look, we can see a value of 65% or even greater, more extreme happened here. Out of our 100 simulations, we can see that a result of 65% or higher only happened 4% of the time. Well, what does this mean? Well, this means that if we assume Danny only had 50% of the vote, like we just did in our simulation, obtaining 65% of the vote in a sample size of 40 people would be very unlikely. Think about it. Only 4% of the time did we actually obtain a result of 65% or higher if Danny actually had 50% of the vote. What that means is that this wouldn't really happen, this 65%, if we only had 50%. Which means this must be a significant number because it wouldn't happen very often with only 50% of the vote. So we can say that the simulation shows very few cases, few because only 4 out of 100, shows few cases with a sample proportion of 0.65 or greater. Again, we're saying greater because these values are to the right of the mean of 50%. So the results from the survey show that Danny will most likely win the election. It's very unlikely that Danny only had 50% of the vote. We can see that Danny probably had much more than 50% of the vote because this didn't happen when we assumed 50%. Well, that's it for today's lesson, and that's it for me. I hope in this video you deepened your understanding for how we can use computer simulations to predict and validate the outcomes of upcoming elections. Until next time.